the differential equation given to us is the derivative of r with respect to s cubed is equal to under root of the second derivative of r with respect to s plus 1. Now before we getting to determining the type and nature of the differential equation, first of all let us simplify by squaring both sides. So now we'll get dr upon ds raised to the power of 6 will be equal to d square r upon ds square plus 1, which will give us the finalized and simplified differential equation as dr upon ds to the power of 6 minus d square r upon ds square minus 1 is equal to 0. Now we need to first of all establish whether this is an ordinary or a partial differential equation. Clearly the derivatives are all taken with respect to one single variable, which is s in this particular differential equation. So therefore what does it mean? That the given differential equation is an ordinary differential equation with, what do we see over here, which is the dependent and which is the independent variable. So we have r as dependent variable and s as the independent variable. Now the next thing we need to determine is the order. Now we know that order of a differential equation is the highest derivative. Now in this case the highest derivative over here is the second order, which means the highest derivative is 2, which means that order of the differential equation will also be 2. And the last thing we need to determine is whether it is a linear or a non-linear differential equation. Since we know that for a differential equation to be linear, the highest power of the dependent variable should be 1. Since over here that is not happening, and instead of that we have a term which is the first derivative raised to the 6th power. So naturally it is not going to make the power of the dependent variable as 1. So therefore what can we write? That since highest power of dependent variable is not equal to 1, so it implies the given differential equation is non-linear. So let us now quickly recap. So therefore what can we say? That the given differential equation is an ordinary differential equation which is of second order and non-linear in nature. So final answer will be that the given differential equation is an ordinary non-linear second order differential equation.